The present discussion, we have to concentrate on divergence of a vector. The concept divergence is taking place, its vital role in fluid dynamics. Divergence is the amount of flux per unit volume. If the amount of fluid at a point decreases with the time, the divergence is positive. Here fluid stands for both liquid and gas. This is or a tank which is filled with water. If the divergence is positive, because if the pipe is open, the water is coming out of the tank. So with respect to time, the water is decreasing. So the divergence is positive. But if you collect the water with the help of a container, here the divergence is negative because here water is converging. In between, while the water is passing through the pipeline, the divergence is zero, because if the amount of water getting in is equal to the amount of water leaving out, the divergence is zero. But as far as the source is concerned, the amount of water is gradually decreasing. But as far as the sink is concerned, the amount of water is increasing. Here the convergence is taking place. So the divergence is negative at the sink, divergence is positive at the source, but the divergence is zero while the water is flowing through the pipeline. In this way, we should realize the concept divergence. If the divergence is zero, such a condition is called solenoidal or incompressible. Incompressibility of the liquid, because here the amount of water crossing a particular region is a constant. You know this statement: if the amount of fluid getting in is equal to the amount of fluid leaving out, the divergence is zero. Such a strategy is called incompressible strategy or solenoidal condition. If the divergence of a vector is equal to zero, such a condition is called as solenoidal or incompressible. Now we'll go to the problem. Suppose a vector A is given to you. That is I into x plus j into ay plus k into az. You know the derivative of phi. The derivative is I into dou by dou x plus j into dou by dou y plus k into dou by dou z. This is del operator dot I into x plus j into ay plus k into az. I dot I 1 is equal to dou ax by dou x plus j dot j 1 dou ay by dou y plus k dot k 1, so dou az by dou z. All other quantities are 0. Now we had a scalar. So divergence of a vector is a scalar. Divergence of a vector is a scalar. In the case of Gauss law of magnetostatics, you know that div B equal to 0. Automatically, you may write B equal to curl of vector potential. B equal to del cross E. B equal to del cross E. This is vector identity. Div of curl of a vector equal to 0. Div of curl of a vector is equal to 0 is an identity. Therefore, we may say divergence of a vector is a scalar. This is the solenoidal condition. Now we will go to a problem. If r power n into vector r is solenoidal, the value of n is option A 3, option B 2, option C minus 3, option D minus 2. Now I have to find out the value. You know that the position vector r equal to I into x plus j into y plus k into z. Then r dot r, vector r dot vector r, which is equal to r square, which is x square plus y square plus z square. If you take the dot product, I dot I 1, x into x square, j dot j 1, so y into y square, k dot k 1, so z into z square. Then vector r, then scalar r square is x square plus y square plus z square, then r equal to x square plus y square plus z square inside the root. R you have to write x square plus y square plus z square power half. In the given problem, f is equal to r power n into r vector is solenoid. The vector f is solenoidal, therefore solenoidal condition is del dot f is equal to 0. Now I into dou by dou x plus j into dou by dou y plus k into dou by dou z is a del operator which is allowed to operate on r power n into vector r. Here r is x square plus y square plus z square power half. R power n is x square plus y square plus z square power n by 2. R is this much, r power n is x square plus y square plus z square power n by 2 into vector r. Vector r is I into x plus j into y plus k into z, which is equal to 0, because in the problem they have given it is solenoidal. Solenoidal means div of a vector is 0. Now I dot I 1, this is dou by dou x of x square plus y square plus z square power half into x. Then j dot j 1 plus dou by dou y of x square plus y square plus z square power half into y plus dou by dou z of x square plus y square plus z square. These are all power n by 2. N by 2, not 1 by 2. N by 2 into z entire is equal to 0. Say I dot I 1. So x square plus y square plus z square into power of power n by 2 into x. Then this dou by dou is allowed to operate j dot j 1, This dou by dou y is allowed to operate on is x square plus y square plus z square power n by 2 into y. K dot k 1. So dou by dou z is allowed to operate on x square plus y square plus z square power n by 2 into z. Entire is equal to 0 because diagonal of this given vector is solenoidal. So diagonal of this vector is 0. Now make our differentiation. If you differentiate this, you have to follow UV formula. N by 2 x square plus y square plus z square or n by 2 minus 1 into 2x into this x. Then differentiate with respect to x. Dou by dou x of x is 1. We have to write the term as such: x square plus y square plus z square power n by 2. So this differentiation is over. This is n by 2 x square plus y square plus z square over n by 2 minus 1 into 2y into y plus x square plus y square plus z square power n by 2. Because dou by dou y of y is 1. And the third term plus n by 2 x square plus y square plus z square over n by 2 minus 1 into 2z into z plus x square plus y square plus z square over n by 2. Entire is equal to 0. This n into x square plus y square plus z square over n by 2 minus 1. 2 to get cancelled. X into x square plus here 2 to get cancelled. N into x square plus y square plus z square power n by 2 minus 1 y square. In the same manner, plus n into x square plus y square plus z square n by 2 minus 1 z square. Just we are combine these three terms. X square plus y square plus z square for n by 2. Here x square plus y square plus z square for n by 2. Here one x square plus y square plus z square for n by 2. Just we have to add this. Plus 3 times x square plus y square plus z square power n by 2. Entire is equal to 0. Now take this n into x square plus y square plus z square power n by 2 minus 1 as a common term. So rest of the terms are x square plus y square plus z square. Here plus 3 times x square plus y square plus z square power n by 2. Entire is equal to 0. This is actually x square plus y square plus z square power 1. So if we combine these two terms we can get n into x square plus y square plus z square over n by 2 plus 3 times x square plus y square plus z square over n by 2. Entire is equal to 0. If you take this x square plus y square plus z square for n by 2 outside, we may write n plus 3, which is equal to 0. Therefore, the value of n equal to minus 3. From this, we may write the value of n is equal to minus 3. Therefore, the option C is correct. If r power n into r vector is solenoidal, the value of n is minus 3. If A is a constant vector, the value of del dot A cross R is option A 1, option B 0, option C minus 1, option D 3. Here A is a constant vector. We have to find out the value of A cross R. Vector A cross vector R. I, J, K is A1, A2, Rx, AY, AZ. R vector is X, Y, Z. Now we have to find out this I into AY Z minus AZ into X minus J into AX Z minus AZ into X plus K into AXY minus AY into X. This is I into AYZ minus AZ into X. Just to change the sign. Minus J is modified as plus J. So AZX minus AX Z plus K into AXY minus AY into X. This is the value of A cross R. Now we have to find out del dot A cross R, which is equal to, say, I into double dou X plus J into double dou Y plus K into dou by dou Z dot this A cross R. This is a cross R value. Say I dot I1. Now we have to write dou by dou X of AY Z minus AZ into X. See that AYZ is I into AYZ minus AZ into Y, not X. AZ into Y. AZ into Y. Then J dot J 1. Therefore, plus dou by dou Y of AZ X minus AXZ plus K dot K Here the across R value is this much. K dot K 1. So dou by dou z of AXY minus AY into X. See here. Dou by dou X is an operator which is allowed to operate on this quantity, but no X term is present here. So the value is 0. Dou by dou Y is another operator which is allowed to operate on this function. Here no Y term is present, so this value is also 0. Dou by dou Z is the third operator which is allowed to operate on the things available inside the bracket, but all the terms are free from Z, so this value is also 0. Therefore, the entire answer is 0. Del dot A cross R equal to 0. So the option B is correct.